So we're pretty familiar with surface integrals in general because I did a ton of examples with the scalar fields. So hopefully I can just do one example with a vector field. And I'm going to make a word problem so it's extra juicy, but we'll be able to see the word problem and hopefully also some of the mechanics. Okay, so water is going to flow into a sphere of radius 1 centered at the origin. Okay, easy sphere. And it's going to flow along this vector field. So what does that mean? That means we have a sphere of radius 1 centered at the origin. And this vector field 0, 0, negative z. So like wherever we are, like if z is 1, we're going here. And then these actually get smaller and smaller until z is 0. 0 here, and then negative z, but z is negative, so it's actually going to start going up. And these get bigger and bigger here, and then smaller again. Okay, so that's what that looks like. So water's coming in everywhere, coming in pretty slowly near the outside, coming in pretty quickly at the north and south poles. So we expect a positive answer because we're coming in. And let's keep track of that. Okay, so let's try to start doing it. So our surface is the sphere of radius 1 centered at the origin, and we can parameterize this sphere. We're pretty good at this now. Let's use spherical coordinates. That'll probably give us the easiest integration, where rho is fixed at 1, right? Rho equals 1. So we just need the phis and theta. Sine phi, cosine theta, sine phi, sine theta, comma, cosine phi. That's the parameterization. That's a parameterization for a sphere of radius 1. And it parameterizes the entire sphere. Okay, so let's start calculating our phi. We've done this before. We'll do it more times. You'll get pretty tired of this in this section. However, it's required to solve this problem. And then r theta. Let's see, negative sine phi sine theta, comma, positive sine phi cosine theta, comma, 0, because z-coordinate doesn't depend on theta. And then we need a cross product in order to calculate a flux. So flux is just everything we did up here. So we're figuring out this. Now u and v are phi and theta, so we're just calculating this cross product right now. All right, so we've got I, let's leave some room, j, k, and write down everything we just wrote down. Sine theta minus sine phi, and then we have minus sine phi sine theta, sine phi cosine theta, and 0. Okay, calculating that, let's see, this is 0 minus negative, so positive sine squared phi cosine theta, comma, and then remember we have this plus minus plus here, so here's the minus. We're going here, 0 minus negative, negative, and then there's this minus here, so total of positive. We have sine squared phi sine theta, yeah. And then the k, there's two things, but remember it was sine phi, cosine phi, and then cosine squared theta for the first one, and then minus and negative, so positive, and it was sine phi, cosine phi, and then we had sine squared theta. So this part was 1, so we ended up with sine phi, cosine phi. We've done this before. We had 3s the previous time we did it, but pretty similar. Okay, so here's the vector, and the new thing we need to do, other than take a dot product and not take a magnitude, and other than the cosmetic differences of vector and scalar integrals, the new thing we need to do is check if we have the right orientation. So the problem might tell you explicitly what orientation you want, or you might have to figure it out. What orientation do we want? The key words here are flows into. So we want the normal vector that we talked about before. Remember, we're somewhere on the sphere. The normal vector could point out, or it could point in, and we have to make a choice. This flows into tells us that we want the normal vector to point in. And this, remember, this cross product tells us what the direction the normal vector is in. So we've got to choose. So right now, it's chosen for us. And what is actually happening is, if you remember from 126, A cross B equals negative B cross A. So I could have, this order phi and theta wasn't sacred. I could have swapped them, and I would have gotten the negative. So I'm either going to choose it to be exactly what I got, or I'm going to take the negative if the problem tells me to go in the other direction. So flows into the sphere. It's a little bit hard to tell in general which direction this vector is pointing in, so we're going to choose a point on the sphere. Probably one of the poles is the easiest. I'm actually going to choose this like east pole over here. So here, why am I choosing this? Because phi equals pi over 2 and theta equals 0. Those are kind of some easy values. We could have chosen another point. So flowing into, meaning I want the vector to point this way. Let's just check what direction this vector points in. So if I sub in phi equals pi over 2 and theta equals 0. So sine of pi over 2 is 1, and cosine of 0 is 1. So I get 1, comma, sine of pi over 2 is 1, sine of 0 is 0, so that's 0. Sine of pi over 2 is 1, cosine of pi over 2 is 0, so 0. So this vector, as is, actually points the other way. So, in order to solve the problem wants flowing into. I could just solve it without doing this and then negate it at the end, but that's a lot to remember. So what I'm going to do is I'm going to take the negative of this. So I'm going to integrate over the sphere. I want the whole sphere. So phi is going to go from 0 to pi, and theta is going to go from 0 to 2 pi. I need my f function, 0, 0, negative z. Z is cosine phi. All right, so I've got 0, 0, negative cosine phi, dotted with maybe this, but maybe the other orientation. And actually here I checked, this is the wrong orientation. This flows out. So what I'm going to do is I'm going to take the negative of all those. So that's the one extra step you need to do. You might need to negate this vector depending on the orientation. Okay, and then whatever that dot product works out to, and let's see, phi is on the inside. So d phi, d theta. Okay, then I calculate the dot product, which is good because there's lots of zeros in the first vector. So it's really just this last thing times this last thing. Negative and a negative make a positive, so that's great. So that's sine phi cosine squared phi. There's no thetas. D phi, d theta. And then I need a little bit of u substitution. So u equals cosine phi du, more negative signs, my favorite. Sine phi d phi. I'm going to sub out the sine phi d phi for a negative du. Okay, 0 to 2 pi. This is phi, goes from 0 to pi. Negative u squared du d theta. Okay, so then that integrates to u cubed over 3, negative u cubed over 3, and I'm just going to go ahead and sub that back in. So cosine cubed phi over 3. Going from 0 to pi, and then eventually integrating with respect to theta as well. Okay, so cosine pi is negative 1. Negative 1 cubed is negative 1. This is negative. So actually, after all the negative signs are done, this problem was very difficult because there were a ton of negative signs. That's positive 1/3, and then minus a negative, so that's a plus. Cosine 0 is positive 1, so plus another 1/3, integrated with respect to theta, from 0 to 2 pi, so I'm just going to end up with 2/3 theta going from 0 to 2 pi, which is going to be 4 pi over 3. So let's just check back with our expectations at the beginning. We said we expected a positive answer because when we drew the picture, the water seemed to be flowing into the sphere as we wanted. And we did. We got a positive answer. So if you were actually doing physics or something, you might be thinking about the rate of time at which the flow happens. But this is the answer to this problem as worded.